Okay, so 3.5, we did a lot of solving quadratic equations, and we used a bunch of different techniques, and one of them involved our quadratic formula. Well, 3.6 talks about how many answers should you really be able to find. And for that, we have to look at this part that's underneath the root sign. That is our discriminant, okay? So this b squared minus 4ac, this part that's under the root sign, that's really important. So we call that the discriminant, b squared minus 4ac. And the whole reason that one's important is because I'm taking a square root of a number. So if I'm taking the square root of a positive number, I'll get two answers because I'm going to plus or minus a number. If what's underneath the square root is a 0, well, it doesn't matter if I add or subtract it, I'm going to still end up with one number. So if this is under 0, I'm only going to have one answer. And if it's negative, well, can we take the square root of a negative number? No. So then I will have no answers. Okay. So just to make sure we get all that, I wrote it all out for us. Let's see what it looks like. Remember, quadratic turns, correct? So 2 zeros. So when the discriminant is a positive value, that means my quadratic, whether it goes up or if it goes down, doesn't matter. That means that that quadratic is going to cross the x-axis in 2 places. So if that's my x-axis, I've crossed it in 2 places. If this is my x-axis here, I've crossed it in 2 places. So this goes with scenario 1 for when my discriminant is positive. Okay? So that's what's underneath my root sign when it is positive. I'm going to have 2 x-intercepts. 2 x-intercepts. And remember, x-intercepts, those are your zeros, those are your roots, those are your solutions. I don't know, they keep coming up with new names for it. All right, now if it's equal to 0, well, that's the scenario when you turn around, when your quadratic is turning around, and the vertex is actually on the x-axis. So I didn't do a very good job. I should have maybe done my axis first. So let's say that's my x-axis. So this scenario, that's when my discriminant is 0. B squared minus 4ac equals 0. So this is the situation when I have 1 real root. Technically, it's 2 equal real roots, but whatever. So I have 1 root because my vertex is on the axis. My third scenario that we're going to worry about, well, when it turns, it doesn't have to cross the x-axis. So if I'm turning without ever touching the x-axis, well, that's when there is no x-intercepts. So some solutions have no answer. So no solutions. And that happens. And that's okay. So that's when what's underneath your square root is less than 0 because you are not allowed to take the square root of a negative number. All right, I'm not going to do very many of these ones, but let's do a quick one. How many zeros is the question? This is example 1 from page 179. My function is negative 2x squared plus 12x minus 18. So to figure out how many zeros, we're going to use our discriminant, which we know is b squared minus 4ac. We're going to sub in our values. So that means we need to pick out our coefficients. So we've got, the first one is a. The one attached to the x is our b. And our c is our negative 18. So b is 12, so we've got 12 squared minus 4 times a, which is negative 2, times c, which is negative 18. Pop that in your calculator or do it by your brain. 12 squared is 144. Negative times a negative times a negative gives me a negative. And 4 times 2 is 8 times 18. Hey, look, that's 144. So what's my answer? 0. Ah! And as we know from our options, when it's 0, so since b squared minus 4ac equals 0, therefore there is 1 root. So that's the scenario where, let's see, we're a negative, we're going down, right. It's going to have a vertex on the x-axis. Okay, so what we are going to spend the time on is we're going to look at example 3, page 183. So this is one where I give you a function that has an extra letter in it. So this time I'm going to use a k, and I want to figure out the value of k so that the quadratic function only has 1, 0. So I'm still going to use my determinant, and this time I'm going to start with my determinant. I'm going to set it equal to 0, and then I'm going to solve for k. Ready to try this? All right. Pick out our coefficients. So a will be equal to 1, b will be negative k, and c will be equal to 3. We're going to write down our discriminant, b squared minus 4ac, and because we only want 1, 0, we're going to set it equal to 0. All right? We're going to sub in our numbers. So b is this negative k squared minus 4 times 1, because that was a, times c, which is 3. Set that equal to 0. Okay, let's simplify. Anytime you're squaring a negative, it comes out positive. So we have positive k squared minus 4 times 1 times 3 is 12 equals 0. Let's bring that 12 to the other side. So instead of minus, we're going to plus. So we're going to plus 12 to both sides, and that means that k squared equals 12. Take our square root of both sides. And don't forget, when we square root it, we're going to have to do a plus and a minus in front of it. Okay, so let's just finish up. So that means my k is actually going to have 2 answers. So that means that k is going to be equal to plus or minus the square root of 12. And we did all that wonderful work with radicals, so just simplify it a little bit. Let's see. We know the square root of 12 is 4 times 3. So that means plus or minus 2. Root 3 is my answer because the square root of 4 is 2. And there you go. If k is positive 2 root 3, this function will have 1, 0. And if it is negative 2 root 3, this whole function will have 1, 0. Okay, so I'm going to add a couple of examples here, so that way you can see a few more scenarios with this one. Let's find k for this function, so 3x squared plus 4x minus k, and this time I want it to have 2 answers, so I need it for 2 zeros, which means I'm going to use my discriminant, and I need to figure out when that discriminant is going to be bigger than 0. Okay, I need a positive answer on that one. So because I'm going to use my discriminant, let's pick out our a, b, and c. So a is 3, b is 4, and c will be negative k. Discriminant, let's write that out. We know is b squared minus 4ac. And in order to get 2 zeros, I need to solve this for when that solution is greater than 0. Okay? So b is 4. So we're going to have 4 squared minus 4 times a, which is 3, c, which is that negative k, and I need my answer for when it's all greater than 0. All right. 4 squared is 16. Negative times negative is a positive. 4 times 3 is 12, k, and we need it for when it's greater than 0. Okay, so there's just a little bit of rearranging left to do. Let's move our 16 to the other side. So instead of plus, we're going to minus it from both sides. So that leaves us with 12k greater than negative 16. To move the 12 to the other side, let's divide both sides by 12, which gives us k is greater than negative 16 over 12. 4 goes into both, so that would give us 4 over 3. So for any value greater than negative 4/3, this function will give us 2 zeros. Therefore, there will be 2 zeros for all values for k greater than negative 4/3. Okay, let's do example C here. So this time, I want to figure out what values of k will cause my function to have no solution. So no solutions means that my discriminant, b squared minus 4ac, is less than 0. Because remember, we can't take the square root of a negative number. Okay, so let's look here. My a is going to be k, my b is going to be negative 3, and my c is going to be positive 10. So let's plug those into our equation and see what happens. So b we said is negative 3 squared minus 4 times a, which is our k value, times c, which is 10. All of that is less than 0. Negative 3 squared gives me 9, minus 4 times 10 is 40. Okay, and that's all still less than 0. We're going to divide both sides, or not divide, we're going to move our 9 first. So instead of plusing, we're going to minus 9 from both sides. So we've got negative 40k is less than negative 9. Now I don't know how much experience you have with inequalities, but when I divide by a negative number, I actually have to flip the sign. So there's negative 40. When I divide both sides by that, I actually have to flip my sign, which means k has to be greater than positive 9/40 in order to satisfy my question. So therefore, f of x will have no solutions when the k value is greater than 9/40.